Hello everyone, we are solving question 36 of GATE 2018 Chemical Engineering paper from the subject of heat transfer. The question is, vapor balance, vapor bubbles are formed in nucleate boiling regime at frequency of 10 bubbles per second per nucleation site. There are 100 nucleation sites per meter square of heating area. The latent heat of vaporization and density of vapor under operating conditions are given as 1000 kJ per kg and 1 kg per meter cube respectively. The diameter of each bubble is 10 raised to minus 3 meter. Assume that the entire heat supplied is used for vapor generation. The heat flux in watt per meter square of heating area is dash. So for this given boiling scenario in this nucleate boiling regime, we have been asked to find the heat flux in watt per meter square of heating area. So yes, so let's just consider this is a vessel, and from here we are providing the heat. We are having the fluid inside the vessel, and in this nucleate boiling regime, so bubbles will start forming at the surface. So let's just consider these are my bubbles, and these bubbles will help to exchange the heat. So now from the given question, we will write the data. So vapor bubbles are formed at the frequency of 10 bubbles per second. So let's just call this frequency as small n is equal to 10 bubbles per second per nucleation site, and then there are 100 nucleation sites per meter square. Let's just call this as capital, and this we are given as 100 nucleation sites per meter square of heating area. The latent heat of vaporization, so that is, let's just call it as Q vaporization, as 1000 kilojoule per kg, and then density of vapor, raw vapor, we have been given as 1 kg per meter cube. The diameter of the bubble is 10 raised to minus 3 meter. Assuming that the entire heat supplied is used for vapor generation, the heat flux is given as. So here we have been given that the entire heat supplied is used for vapor generation, and we have been asked to find the heat flux. So basically the heat flux, we can write this as heat flux is equal to, see, here we are providing heat and then the bubbles are formed over here. So basically these bubbles will be having this latent heat of vaporization. So and that will be used to further boiling of the liquid. So that at total heat flux we can write it as the number of bubbles into the heat provided by each of these bubbles. So that is heat supplied by, let's say, one bubble. So we have, and this we have been given as, this is Q vaporization. So ultimately we have to find the number of bubbles and then multiply it by Q vaporization, and we can get the total heat flux. So to find the number of bubbles, let's just find the total volume of the bubbles. The volume is defined as 4 by 3 pi r cube. This we can write it as pi by 6 d cube. The diameter of bubble we have been given as 10 raised to minus 3 meter. So the volume of the bubble is pi by 6 into 10 raised to minus 3 meter cube. Similarly, the mass of the bubble, we can find it as mass is equal to rho into V. The density we have been given as 1 kg per meter cube. Ultimately, the mass will become same as volume 10 raised to minus 9. Minus 9 kg. Now here we have been given Q vaporization per kg of bubbles. So let's just write it over here. Q vaporization we were given as 1000 kilojoule per kg of bubbles. So ultimately we can find this Q vaporization as heat supplied to form so we will multiply this by the total mass of the vapors. So that is 1000 into the mass of the vapors. We have found it over here. This will become pi by 6 into 10 raised to minus 6. So yes, this 1000 was in kilojoule per kg. So this will become, let's just change this kilojoule into joule. To joule. This is for each bubbles. Q of bubbles will become pi by 6 into 10 raised to minus of 3 joule. So now to ultimately find this heat flux, we have to multiply this pi by 6 into 10 raised to minus 3 into number of bubbles. So the number of from this, so we are having 10 bubbles per nucleation site. 10 bubbles for one nucleation site, and we are having total 100 nucleation sites. 100 nucleation sites. So for these 100 nucleation sites, we will be having 100 into 10, that is total 1000 bubbles. So yes, we can multiply this by over here. That will become pi by 6 into 10 raised to minus 3 into total number of bubbles, that is 1000. So ultimately the heat flux will become pi by 6. So this will come around 0.5235 watt per meter square. So the final answer is the heat flux will be 0.5235 watt per meter square. So that we can round off till third decimal places as 0.524. So the final answer, that is the heat flux, is 0.524.